All right, so before we finish the notes for section 5.5, just make sure everybody is on the same page for when we're wrapping up this chapter and having our tests and whatnot. So today on the 13th, you worked on section 5.4 for the homework, and we did the notes for 5.5. Okay, and that's what you're going to finish watching the video of right now. So on the 15th, that means that the 5.4 homework is due, and during this class, you will work on section 5.5, and we will also do some like review slash practice, whatever, for the whole chapter. All right. And then on Friday. So on Friday, you're going to take a test on chapter 5, part 1. And that part is going to be kind of like the quiz that you did with partners and in your groups before break. All right. So it will be like 50 to 60 points of your test, and you are going to be able to work together, and I'll check it along as you go. So most likely that's going to be, you'll get a 50 out of 50, 60 out of 60, like whatever that part is. So I'm going to have a little bit from the whole chapter on those problems, and then when you come back on the 22nd, you will take the test part 2. So that'll be about 5 questions, and it'll be worth the last 40 or 50 points, or 45 points, whatever, of the test grade. But that will be by yourself. And so it'll be about, 5 questions or so all by yourself, and probably, you don't need the whole period most likely. All right, and then the quarter is over right here. This test will go on second quarter, and that'll be that. So if you're absent for any of that, make sure you come in, get it done. All right, so let's finish up our notes here. So we went over double angle formulas in class. We got to the notes on there. And so if you were absent, you can pause and copy that down. Then we continued some of our examples there. And finally, we also did the power reducing formulas. Now we only got partway through, and so our power reducing formulas we also need to do for example 6. So I'm going to do these last couple examples. All right, so in example 6, I have to solve an equation here. So I'm going to, let's see, cosine squared doesn't need to be changed. Now with cosine 2x, there are 3 different formulas I can use for cosine 2x. So remember, pick the one that's best. In this formula, or in this equation I'm solving, I have cosine squared that I just wrote down. So I think I'm going to pick this guy right there, 2 cosine squared minus 1. So I have like a like term, basically. So I have minus, and I'm replacing cosine 2x with 2 cosine squared minus 1 equals 1/2. All right, so let's clean this up. I got cosine squared minus that parentheses there. So I have cosine squared x minus 2 cosine squared x plus 1 equals 1/2. All right, so let's see, I'll have negative cosine squared. I'm going to move that 1 over, so 1/2 minus 1 is negative 1/2. My negatives cancel, so I get cosine squared equals 1/2. All right, so I do the square root. I get cosine x equals plus or minus the square root of 1/2 is 1 over radical 2, which is radical 2 over 2. So it's 45 degrees. So I'm looking for all solutions. So all 4 quadrants, because it's plus or minus, so pi over 4 here, 3 pi over 4 here, 5 pi over 4 here, 7 pi over 4 there. So you could start off like this. You could say pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n, 5 pi over 4 plus 2 pi n, and 7 pi over 4 plus 2 pi n. But these 2 answers right here are spaced pi apart. So why don't I just say pi over 4 plus pi n, and I'll knock those 2 out. Then I can also say 3 pi over 4 plus pi n, and knock out the other 2. So there are your solutions, all of them. All right. So the last set of formulas that we're going to do in this section, and I said in 5th period, I forgot to say in 1st period, this section, section 5.5 in the book, has many more formulas and many more identities. We're only doing the first 3 sets of them. There are others in there, but they're just not as commonly used, and if you ever needed them, you could look them up. They're not that big a deal, but these are like the more common ones. All right, so sine of theta over 2. This formula or identity goes like this. Plus or minus, I'll talk about in a minute. Big square root, 1 minus cosine over 2. So it looks a little bit like your double angle formula, except it has a square root and a plus or minus in front of it. And cosine theta over 2 is plus or minus big square root 1 plus cosine theta over 2. And tangent has a few different formats. Plus or minus square root. And you got 1 minus cosine over 1 plus cosine. So that's when you divide the sine and the cosine formulas from before. But it also has other formats. You can make it 1 minus cosine theta over sine theta. And it can also be sine theta over 1 plus cosine. So all those three things are interchangeable. Now, let's get to why this plus or minus. The plus or minus needs to be decided on when you're doing a problem. For instance, in example number 7, it says find the exact value of sine of 105 degrees. Well, 105 degrees is over here in this quadrant. I know that the sine is positive in that quadrant. So when I choose to do this formula, I'm going to say to myself, well, sine 105 is half of 210, so 210 over 2 is 105. So I'm going to do 210 over 2. And I know that 210 over 2 is 105, and 105 degrees is in this quadrant. Sine is positive in this quadrant. So I'm going to choose to put a plus. So you never use the plus minus. You always choose which one of those answers it is. And then square root 1 minus cosine of 210 over 2. All right, so you got your unit circle. Cosine of 210 degrees is negative square root 3 over 2. So I will say square root 1 minus negative square root 3 over 2 changes to plus square root 3 over 2 over 2. So I'm going to clean this up a little bit. I'm just going to multiply by 2 over 2 inside there so that it makes it a little bit nicer. So that means that the top becomes 2 plus radical 3. That's in a square root. The bottom becomes 4. It's all in a square root. So I'm going to fix it up even more. I'm just going to leave 2 plus radical 3, and the bottom is 2. All right, so over here, tangent of 105. So I'm going to use the same thing. And you know what? I don't really like this formula here, because I have to decide the plus or minus. Why don't I just use, I don't know, I think I'm going to use this formula right there. All right, so I'm going to say the tangent. I'm going to use, again, 210 divided by 2. Which is 105. All right, so I'm going to do 1 minus a cosine of 210 over the sine of 210. So again, the cosine at 210 is negative square root 3 over 2. So it'll turn into 1 plus radical 3 over 2. And on the bottom, it is the sine of 210, which is negative 1/2. So I'm going to flip the bottom up, so it'll be like I'm multiplying by negative 2 over 1 when this thing flips up. So that means I get negative 2 minus radical 3. Oh, sorry, I thought I paused the video. I was doing something. All right, so let's use it one last time in our solving here. So I got 2 minus sine squared x equals 2, and then this is cosine squared of x over 2. So I'm going to take this formula and I'm going to square it. So I have plus or minus. I have a square root. I have 1 plus cosine theta over 2. But remember, if I'm plugging that in here, it's squared. So the radical is going to go away. When you square a plus or minus, it's just plus. So you're going to get 2 times 1 plus cosine theta over 2. So those 2's are going to cancel. All right, so I have 2 minus sine squared equals 1 plus cosine theta. All right, so hopefully by now you noticed that that sine squared, I'm going to end up changing it. So 2 minus sine squared is really 1 minus cosine squared equals 1 plus cosine, oh, theta? Oh, x. Whoops. I guess that should have been x's all along. And this one too. All right, so I get over here 2 minus 1 plus cosine squared equals 1 plus cosine x. So this is a quadratic. I got cosine squared. Let's see, minus cosine x to bring this guy over. And then over here I have 2 minus 1, which is 1. And then this one over here on the right cancels, so equals 0. All right, we're going to factor out a cosine. Get cosine x minus 1. So this is cosine equals 0. This one's cosine equals 1. So cosine is 0 at 0 and, I'm sorry, at pi over 2 and 3 pi over 2. Cosine is 1 at 0 and also 2 pi, but that is not included. Let me see what I said in the question. Okay, so it said solve. So it did not say to stop at 2 pi n. I mean, it's to stop. So if I was going to say all the answers to this, I would say x equals pi over 2 plus 2 pi n. But if I do plus pi n, it takes care of both of these. And then I could also say x equals 0 plus 2 pi n or just 2 pi n. That would be it. All right, I'll see you in class. Bye-bye.